Today we'll be discussing on how to install your Kubernetes by using Kubeadm, how to install your cluster on your virtual machines. Okay, so all that is what we are going to discuss today. So we'll be discussing how to create cluster by using Kubeadm in your virtual machines. So why do we have to go with Kubeadm? See, we have a lot of methods are there, right? Let's say if you talk about installing cluster, we have like Minikube, Kind, Kubeadm, K3, Rancher, cloud platform like AKS, EKS, GKE. Why do we have to go for Kubeadm? See why? Because especially this Kubeadm will actually give you the production level setup. Okay, so it is going to give you the production level control. So where you can actually work on a lot of things, like you can set it up of your own infrastructures, and you can work on the volumes. I mean, like setting up your storage classes, then related to networkings. So creating your own setting up your own networking so for your CNI. Okay, so this is where your Kubeadms works properly. So basically Kubeadm is an official Kubernetes tool used to bootstrap clusters, initialize the control plane, join your worker nodes, manage certificates, okay, and configure cluster components. So it does not install OS dependencies and all. It install only container runtime, okay, configure networking automatically, and you need to do this manually, okay, to give production level control. So which means what you need to do, you need to install this container runtime, and you need to install this CNI, that is container network interface. Okay, so yeah, so what are all methods we have for cluster? So we have like Minikube, Kind, and Kubeadm, K3. Then we have Rancher and Cloud Platform. See, we can't go with Cloud Platform because it's gonna charge. Okay, so uh, like if you go for AKS, Azure Kubernetes Service, or Elastic Kubernetes, if you're using AWS, or GKE, Google Kubernetes. Okay. Enterprise. So if you're using this cloud platform, definitely they're gonna charge you, right? So we can't use this. Okay, so that's the reason what we are going to do here is we'll be going with the Kubeadm part. See, we can even go with Minikube. Minikube is like what is going to happen here is it is just like a it just going to create a cluster where you'll have only the control plane. Your worker nodes will be like in the virtual machine setup. Okay, so you cannot work like how you work in like Kubeadm. Okay, so there's a lot of difference are there. Okay, now if you look into the installation method comparison, okay, you can able to see that we have this features. Okay, what are all features we have? So can you able to work on multi-node? If you're using Minikube, no, we cannot use multi-node. Okay, whereas if you look at Kind, it is simulated. Okay, if you want, yeah, but in Kubeadm, definitely we can use this. Okay, and even in K8, we can use this. Okay, yeah, if you look at the production level, when you compare with Minikube and Kind, you can definitely use Kubeadm in the production level. Okay, and complete infrastructure control will be happen in the Kubeadm. It's fully controlled. Okay, and networking part also it is going to be advanced. Okay, and storage parts also it's going to be full. Okay, so you can learn in depth. Okay, by using Kubeadm. If you're going with Kubernetes, right? So if you want to know more detail about this Kubernetes, let's say in future you're going to work on Helm, or you're going to work on the storage classes, or you're going to work on the networking related services. Okay, I think the Kubernetes is the best part. Okay, is that clear, Elvis?
Yes, that is clear. So, CubeADM, from what you're saying, what about? I know you just said EKS is kind of costly,
Yeah.
and but I'm asking for production level organizations. Most organizations, what are they really using? I know they're using EKS. That's when they're going with AWS
See, that's what
platform.
in production level, yeah. See, if you want to understand, okay, or if you want to work on all kind of components, see, in production
Hmm.
level, you work on all the components, right? You work
Hmm.
on storage classes, you work on networking, you work on a lot of things, right? As or no?
Yeah.
Yeah, so that you can do it with the help of Kubeadm. Okay, so in
Okay.
Kubeadm, you create your own infrastructure. Like you create a worker node and you create a master node and you make them to communicate. Okay, yes, so that you can do it. Okay, but whereas if you look at in cloud environment like EKs and all, no, so that EKs component at all, it's all been managed by your
Mm-hmm.
AWS itself. Okay, so you are not going to manage anything. Maximum you can give role and you can assign some policies to your cluster and all. Okay, but here we are only going to manage. Complete control is going to be with us. Got it right? So that is what you
Yes.
can see.
Yes.
Infra control is actually full here.
Okay.
Okay, yeah. So why Kubernetes? Because we are gonna work on the real infrastructure experience. You get the real infrastructure experience, like how actually we can form a cluster. In that, how that master node is going to be there, how this worker node is going to be there. Yeah. So which is going to have the control plane setup. Okay, and your certification management and your etcd clustering. So you will have the real production knowledge if you're going with Kubernetes. Okay, yeah, and full networking control you can. So you can use CNI yourself. That is like a container network interface. Okay, so we have a lot of CNIs, like we have Calico, Cilium, Flannel, Wave, but most probably we'll be using Calico only. Okay, so Calico is the best networking interface that are actually useful for making your containers to communicate with each other in the cluster level. Okay, understood, right? Is it
Yes.
clear? So this is like
Yes.
cluster networking interface. Okay. So sorry if I've told like container. Yeah, it's a cluster networking interface, not a container networking interface. Okay. So if you observe here, yeah, you can able to see like we have these many components are there. Okay. Yeah. So basically what it helps, it actually helps the pod CIDR service routing and networking policies. Okay. So that is what this cluster networking interface is going to do. Next, if you
So
talk about,
are we going to use Cilium or we are going to use Nginx?
no, we are going to use Calico.
Okay, Calico. Calico for
Calico,
me.
yeah,
Okay.
most probably we'll be using Calico only. Okay, yeah,
Okay.
yeah. So if you look at the storage and stateful apps, okay, so Kubeadm supports like NFS storage, SEP, and this long and all is like Longhorn is something like a storage class. Okay, you'll understand when I go with storage class, you'll understand this, and a lot of other cloud disk as well. Okay, and it is required for database, netbox, ClickHouse, monitoring stacks. Okay, so we use for storage class for all this purpose. Okay, yeah. So and if you look at high availability, yes, which is going to, you can create like three control planes and you can have a load balancer, external etcd, all that, but it is not possible in minikube or kind. But whereas if you observe in Kubeadm you're gonna have a high availability. Okay, yeah, understood, right? Okay. So next, if you look at enterprise usage, definitely we
Are
can
we,
use it in banking sectors, telecom, government infrastructure, and air-gapped environments. So which means you create your own infrastructures and you can actually, work on multiple platforms. Okay, yeah. So now let's see how to install this Kubeadm. Okay, let's try to see.
if we want to do like auto scaling, are we going to install any other tool when it comes to auto
Ah,
scaling,
so
or are we going to do it manually?
man only. Man
Okay.
only.
Okay.
Okay, we have to
Okay.
use man only. Okay,
Okay.
man only we have to do it here. Understood, right? Yeah. Okay. Yes. So now if you observe here in Kubeadm installation, so it's going to be the detailed flow. So yeah. So let's say for example, what and all is required. So basically we need kernel modules. We need this networking part. Okay, then we need to disable your swap. We need to disable your SLNX. We need to disable your firewall. Why? Because so that if this SLNX or your firewall is there, so the communication between your master node and worker node will be hard. So we need to disable your firewall and we need to disable your SLNX so that they can have a free communication with each other. Okay, yeah, they can communicate with each other. Then we need to have a container runtime. You know why we need container runtime? So that we can make our uh, particular containers to run and up, so that we can run. End of the day, our application is going to be up. Okay, yeah, yeah. So let's talk about this. Let's say, for example, okay, yeah, if you observe here, so if you talk about this installing container runtime, basically with the help of container runtime, what and all we can do. So for example, we are going to install a container runtime called container D. Okay, so once you install this, basically this container D is actually responsible for pulling images, running containers, and managing namespaces. So where is this container D going to be? Yes, where actually it is going to be? Where is this actually going to be? It's going to be in your master node or it's in your worker node?
Your worker node.
Exactly, it's going to be in your worker node. All right. Like, let's say, for example, mm, let me go to the downloads. Where is this? Let me write down the entire setup, okay? So you can understand this clearly. Okay. Yeah. So basically, we know, right? If you look into a cluster, so in your master node, we have something like API. Okay, then API server, then we have this scheduler, then we have this control manager, then we have this etcd, right? We have this four components, right? Whereas in your worker node, we have three kinds of services. One is your kubelet, another one is your kubeproxy, and another one is your container runtime. So that is your Docker. Okay, so basically we need these three services, right? Yes or no? We need these three services in your worker node. Because if you know why we need all this. Okay, why? Because let's say for example, okay, if you're in your worker node, so definitely end of the day, all your pods. Oh, okay. I mean the pod is nothing but it's a basically it's a wrapper of your it's a wrapper where it stores multiple containers into it. Okay. Yeah. So now to make this container to run, definitely we need this container runtime, right? So let's say for example, if you look at here, we have this cluster, right? In the cluster, you have this master node and you have this worker nodes, right? So this is master and this is worker. So in the worker node, we need these three components. One is we need this container runtime, that is Docker. Then we need this kubelet, so that end of the day, your kubelet is the one who is going to communicate to your worker node, as well as it is going to be helpful for starting up your pod. Okay, yeah. Then we need this proxy. So proxy is actually useful for making your pods to communicate with each other. Okay, yeah. So basically, it's useful for networking part. Yeah. So now to run your containers up. So by default, we need this container runtime, like container D. Okay, that is your Docker. Okay, yes. So now, end of the day, if your master, see, this entire cluster has to communicate. Let's say your master want to communicate to your worker nodes. So basically, it will be using a set of networkings like canonical network. Okay, sorry, Calico, Calico network part. Okay, yeah, that is what it's going to do here. So in your master, you have like API server. So basically this API will actually act like a gateway. So if anybody who wants to communicate to the cluster using this kubectl command or using the UI part, okay, they have to communicate first to the API. So API is like a cluster gateway, right? Then we have the scheduler. Okay, scheduler is the one who is going to communicate to your kubelet and make your pods to run. Okay, then we have the control manager. So your control manager has a thing like if any changes that is happening in your cluster, okay, that will be noted in your control manager. Let's say if a pod dies or if a pod is being created, so all this control manager will be looking into that. So your control manager will tell to your scheduler and your scheduler will tell to your kubelet. Clear, right? Next we have this etcd. So etcd is like your cluster brain. So basically any changes that is happening in the cluster, everything is going to be noted in the etcd. Okay, clear, right? Is it clear? Hello? Is it clear, Elvis?
Yes, 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 that's clear.
Okay, fine. Now, in our case, what do we actually need? See, we need a worker node and we need a master node, right? Master node and we need a worker node. Is it clear?
Yes,
Now, let's look into the installation part. Okay, let's try to go with the installation part. Okay, so basically, what and all things that we actually need. Let's say you're forming up a cluster, right? So, what and all you need. So, if you want to create a cluster, so by default, we need some things. Okay, let me show you what and all is required here. Yeah, so first we need to have this container D. Okay, yeah, then so because it's responsible for pulling images, running containers, and managing namespaces. Okay, so I'll explain what is namespaces when I go with namespaces. Okay, so first we need to install this container D runtime. Yes, next what we need this kubelet or kubeadm or kubectl. Okay, we need to install all these three: kubelet, Kubeadm, kubectl. You know what is kubelet is going to do, right? It is the one that is going to run the pods. Okay, is it clear? And
yes,
Kubeadm
yes,
is like a bootstrap cluster. So with the help of Kubeadm only, we are going to create a form a cluster part. Okay, then kubectl is for running your commands. Kubernetes commands. It's for CLI access. Okay, yes. Then we have this kubeadm init. See, basically, this Cube ADM init is the one who is going to create this API server, scheduler, control manager, etcd, and certificates. So basically, with the help of Cube ADM, the cluster becomes operational control plane. Okay, is it clear?
yes, yeah. So once you install kubeadm, then you run kubeadm init. That is where you're going to have
Yeah. So yeah.
all
So
the necessary services that are supposed to be
yeah,
available
simultaneously
on
we
the
have to
cluster.
install all these three. Then we have to initialize in your master node. See, whichever
Yes,
machine you are using QADM in it, that machine is going to work like a master node. Okay, it's going to become like a control plane node. So you understand, right? We have a cluster here. So basically, for example, uh, this is a cluster. Okay, in the cluster we have this master and we have the worker. Let's say when I run kubeadm init in my master node, so now this particular machine is going to work like a control plane. I mean, it's going to act like a master node. So in master node means we'll have this API server, scheduler, control manager, etcd, and certificates. Clear, right?
yes,
Is it clear?
yes, yes, yes,
Yeah. So we need to use this QBD minute also. Next, we need to have the CNI. See, CNI is basically for the cluster networking interface, guys. So if without CNI, your pods will not get any IP address. Nodes stay not ready. Okay. So CNI provides cluster networking. Okay, so CNI provides cluster networking. So this is very important. Okay, now next thing is we have to join our workers by providing the token. So once you run this command, no kubeadm init, and when you provide your network address of your master node, right, it will provide a token. Okay, so with that token only, we have to connect our worker nodes. Clear, right? Like how we did it for SWAM. You understood, right? You remember what we did in Docker
yes,
SWAM?
yes, yes, yes,
We
yes,
provide a token, right?
yes,
The same thing here, same thing, same setup here. Okay, yeah, so nothing big difference here. Okay, next, we need to deploy our workloads. Like we need to inside the cluster, we have to create these deployments, and we have to make the service running and ingress stateful set, all that. Okay, so installation is very simple only. So first we need to have an operating system, then we need to install container d, then kube tools, then kube init for your master. Okay, then we have to configure your kubectl command, then install the container, I mean cluster networking interface. Then we need to use the token for making our workers to connect to your master node and deploy the application. So this is the installation command flows. Okay, understood, right?
Yes,
Simple
yes,
concept.
yeah,
Now we'll actually look. See what and all we need in your master node and worker node. So if you have one master node, if you have one worker node, that is fine. Okay, you don't have to create multiple master node or worker nodes. Okay, for understanding purpose. Okay, so make sure your container runtime should be container D. That is very important. And your cluster network interface should be Calico. Is it clear, right?
yeah.
Okay, so this is the node detailed setups. Okay, so first what we should do, first thing is, let me go to my virtual machine. Okay, let's go with my virtual machine. See, now I have this master machine. Okay, now I have this master, right? Yes or no?
Yeah, so
I ha Yeah.
I understand all this, all what you're explaining, but I want to understand what is happening under the hood with EKS. So with EKS, is everything that we are explaining now is already installed by AWS and managed by AWS, right?
No, in AWS we use EK service. Right? EKS by default it is going to create for you. Okay,
Yeah,
so
that's what I'm saying.
yeah, you
So,
have to just
so
give the
everything
rules.
we are not going to install. We don't usually install all these networking services in
Yes, yes,
AWS.
yes, yes. By default it will install for you. Yeah.
Okay,
Okay, so you don't have to worry anything about there. You just need to, there's some options are there. You have to select the option. That's it. But
okay,
here, you are only going to create the infra.
okay.
Okay,
I get it.
we are
I get it.
setting up from the scratch.
Yes,
Okay,
okay,
so you will have a very clear knowledge on once you set up on your own. Okay, so once you set up on your own, then once you work on EKs and all, you'll feel very easy. You'll feel very
yeah.
comfortable.
Hmm.
Because you
Sure.
have the base code knowledge here, because you are the one, you have set up the entire infra here. Because once you have a knowledge on setting up the infra, definitely your cloud plat and all will be very very easy. When you go with ek service and all, you will understand. When you're setting up roles for your worker nodes and all, no, you will understand, okay, why do we need to give this role, why do we need to give this role, you'll slowly understand over there. Clear,
Okay,
right?
okay, okay. Yeah,
Okay,
thank you.
so in my master node, what is the first thing I should do here? See, first thing is we need to first work on the package level manager. Okay, first we need to check with the package manager. This is very important. First, we need to check with the package manager. So, how you're going to check with the package manager? So, you have to run cd slash etc slash m dot repos dot d. When you observe here, yeah, by default, CentOS itself has provided you a two repos. Okay, but none of them are going, we are not going to use none of them, so I'm going to remove all this. Okay, now nothing is there. Now I'm creating my own package. uh, I'm creating my own repo. Okay, I'm just creating my own repository. So what I'm going to do is, let me give like appstream.repo. You can give any name, but for me appstream.repo is comfortable. So let me check where my cd packages are located. It's all located over here, right? Let me copy down this entire path. Appstream.repo. Okay. So first thing is what we have to do here. First thing is we need to mention the repo ID 1234 for AppStream. Okay. Name is equal to AppStream. Then enabled equals to 1. So we are making this repo as enabled repo. Then gpg check equals 0. Then in the base URL, you have to give the entire path of where your AppStream and base OS package is located. Okay, so this is very important. Okay, you understood, right, why we are doing this?
Yes, yes, I get it.
Okay, yeah, so now for base OS also we have to do. So let me copy down the 5 lines. Let me paste it over here. So instead of 1 2 3 4, let me give it as 5 6 7 8. And instead of app stream, let me give it as base OS. Okay, then in the base URL, instead of app stream, let me give it as base OS. BASEOS. Okay, now let me save this and come out. Yes, now let me clean all the cache files. Yes, now check which all the enabled repo are there. M repo list all. I think only two should be there. AppStream and base OS should be there. Okay. See, you can see here AppStream and base OS has been enabled. Okay. Yeah. Same way we have to do it for worker node also. In the worker node also, what you have to do here is, let me change the setup here. So in the worker node, what you have to do here is, so you have to same way create your own repo. Okay, go to your repository configuration file, that is m.repos.d. Okay, remove all the files here, rm-f c star. Okay, now create the same file. Oh, yeah, let me check if I give paste whether it's going to work or not. No, it's not going to work. So run lsblk, copy down the entire path or where the packages are located. Okay, next what you do here is you have to create a appstream.repo. Okay, go here, give insert mode. First thing 1, 2, 3, 4. Okay, then you can give your enable repo. I mean repo name. Sorry. So you give the repo name as appstream. So it should be enabled repo. Make sure enabled equals to 1. Then gpg check equals 0. gpg check gpg check equals 0. Then in the base URL, it's equal to file. You have to give the file protocol, okay? Because it's within the local machine, right? So we have to mention this. So here we just need to give it as appstream slash appstream. Now copy down this file lines 5 by y, then paste it over here. So now instead of 1, 2, 3, 4, just give it as 5, 6, 7, 8. Then in the name, you can just give it as base OS. The base URL path, BASEOS. Let me save this and come out beautifully. Good. Now what you have to do, you have to clean all. Okay, clean all. Yes, we are going to clean all the cache files. Okay, then we have to check which are all the enabled repo now by running yum repo list all. So when you run yum repo list all, you come to know that what are all the enabled repos are there. So right now we should have only two repo, that is your app stream and base OS. Okay, is it clear?
Yes, yes, yes.
See, very simple. We are actually trying to create our own package manager. Okay, so
Yes,
by creating a repository file. Okay, and here we are just storing where your app stream and base OS packages are located. Okay, basically it is located in your CD DVD, right? So we are giving the full path in the base URL in that particular repo file. Okay, if you look into the cat appstream.repo, we are giving the full path. Okay, where actually your AppStream package is stored, where is your base package has been stored. Clear, right? Now in
yes,
future, yeah, in future, if you're trying to install any package, it will go to this AppStream. It will check whether in AppStream we have the package or not. If it is not there, it will go to the base OS and it will find to check in this path. Okay, clear, right?
Yeah. So if it's not in these two part, it's not going to install, right?
Sorry, I didn't get you.
I said if it checks if you're trying to install any package and it's not in these two repos, it's not going to install it
Ah, it's not going to install. Exactly. It's
because
not
you have
going.
because you have taken out the two that was already there.
Yes, yes, yes,
Okay.
yes, yes, yes.
Okay.
So if that, let's say, if you're trying to install Kubernetes package like Kubelet or Kubeadm, definitely Kubeadm and Kubelet is not going to be here, right? It's not
Hmm.
going to be inside this abstract base OS. So in that case, we have to install manually. Okay, I'll show you how to do that. Okay,
Okay.
now if you observe here, yeah, these are the two steps. Next thing, what you have to do, we have to make sure there should be no swap because swap will actually create conflicts in the storage class. So basically, we should not create any swap should be disabled here, and SLNX should be disabled. Firewall should be disabled. So the three things should be there. So then only we can form this as a cluster and we can make your master node to communicate with your worker node. So what are the things that you have to do? First, we have to disable our firewall by running systemctl stop firewall d. Then systemctl disable firewall d service. So I think the firewall d service has been removed. Same way you do it in the worker nodes also. So systemctl.
So if you do it like that and restart the system, say you stop everything and come back tomorrow, is it not going to be enabled?
No, it's not going to.
Because I know you don't put
No,
permanent.
it's not. Yeah, it's not. See, this is permanent method only.
Okay. Okay.
Okay, this is
Okay.
permanent method only. Even if you stop and run, also it is going to run. Okay, it
Okay.
is going to be the same. So that's all. Until unless you're going to start, it's not going to start. Okay. So disable the service. Okay. So right now, the first thing we have disabled firewall. Next, what you do, we have to disable our SLNX. So how we are going to do? See, currently our SLNX status is in get enforce. It is in enforcing mode. So which means protection mode. So we have to change it to permissive. So if you want to change it permissive in permanent way, you can actually run this command set enforce 0. Then you can go to under etc we have this slnx. Under slnx we have this config file. Go to this file. Here you can change it to permissive. So this is going to be permanent method. I think what is the spelling? Permissive. I hope this is correct, right? Anywhere, yeah, permissive, it's correct. So spelling is correct. So save this and come out. That's it. Now if you try to check your current status of your SNX, it is in permissive mode. Same way, go to your worker node also. In your worker node also run this command set40. So we know set40 is going to change from enforcing to permissive. This is temporary method, but if you want to make it permanent, then you have to go with under etc slnx. We have this config file. Inside this config file, we have to change it to permissive. So I think I would have taught you when I'm explaining this SLNX topic, right? Permissive. Yes, let's save this and come out. Now, if you try to check your SLNX current status by running get enforce, you can observe here it has changed to permissive. Now we need to disable all the swap. So to disable all the swap, we need to run this command. That is, we need to run this command swap of -a. So swap of -a is going to disable all the swap, and it's going to comment whatever the swap which is mentioned in the fstab file. Okay, so basically, right, under fstab file, we store all our file system related information. Okay, so to make our file system to be permanent mounting. If you want to go for permanent mounting, we'll go for fstab, right? So if you want to disable all the swap related things, you can copy down this entire command. Okay, just type it over in your two machines. Okay, so in my master node, I'm just going to paste this command. Oh, what happened? It's not going to copy power of this machine, so that's creating a lot of headache. Power off and power on. So the copying part should actually work here. Yeah, see, it worked over here, but not sure why it didn't work in my master. Let me cross check again. Hmm. So right now, what we have done till now, we have what and all we have done. We have stopped the firewall service. We have disabled our SLNX. Then we are offing all the swap related things. Okay. So yeah. So next step is what we'll be doing here is uh, basically, yeah. One second. We'll be installing some kernel modules. Okay, we need to install some kernel modules like overlay. So overlay is for container file system, and we have this BR netfig filter. This is for pod networking. Okay, we need to install these two things. Okay, so we need to install these two things in the ka.config file. Okay, so only if you enable this part, only then we'll be getting this container file system and we'll be getting the pod networking. So this is very, very important. Okay, so next thing is we need to copy down the entire thing, go here. But before that, let me go to this machine, paste it here. Yeah, see, this is working here fine properly. What about in KA master? Gate master also it should work. Let me log in as root user. Sorry, password as red. HAT red. Hmm. Now in the master, I forgot to off the swap, so I have to run from there. Okay, I have to run the steps from there. So what do you have to do? Let's go to the swap. Okay, disable all the swap related things. Copy down this entire part. Okay, go to your master node. In the master node, just paste it over here. Now it will actually stop. Okay, so next thing after doing that, we have to disable. I mean, we have to enable your kernel module. So just run this particular command. Copy down this. Okay, so then go here, paste it over here. Okay, now successfully it is run. Okay, then yeah, we have done it for both master and worker node. The next thing is we need to enable this networking part. Okay, so we need to enable this networking part, only then your pod routing and forwarding is going to happen. So let's copy down this entire thing. So we have to do everything in the kh.conf. So that is actually stored in your sysctl.d, which is stored in your etc configuration directory. Okay. So now what you have to do here, go here, just paste what I have copied here. Just give enter here. Same thing. You have to do it in your worker node also. In your worker node also, copy and paste the entire thing. Okay. Just give enter here. That's it. So now we have added all these things. Okay. So to make your port forwarding and all. Okay, all that. Next we need to install this container d runtime. Okay, so we have to install this container d runtime. Okay, so we have to install on both. Okay, you can do it on both. So let me copy down these two commands. uh, where is my master node? So in my master node, I'm just going to paste this, give enter here. Okay, okay, I forgot to give yum clean all repo list all.
Do we have it in the repo?
Yeah,
The re-
sorry.
do we have it in the repo that we created? Those repo, or we are not using those repo to install these packages?
Yes, 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 yes.
Okay.
Yes, it's going. We have it in our repo. So that's what. See, I have tried to install repo only. I've added this repo. You can see, no, I'm adding a
Mhm.
repo
Okay.
called HTTP download docker.linux centos docker.co. Okay, so it is actually downloaded here. You can see here, even I got the repo
Yeah,
also.
yeah. Mhm.
Okay, I got these many repos. Okay, but in that few are disabled, only one is enabled. Okay.
Okay.
So yeah, no problem. So now same way here also, let me go to this K8 worker. In my K8 worker also, let me paste this part here. So here you can see it is successfully it is installed. Now if I try to check yum repo list all here, I can see same thing here. Understood, right? Yeah. So I got this Docker CE stable repo. From here only I can install the container D runtime. Okay. So from there only the package container D runtime is going to be there. Okay. So now you can just copy down this command dnf install -y container d.io. So this is for runtime. You understood, right? Is it clear?
Yes, yes, yes,
And where
yes.
is this particular runtime is going to come from? Which repo? It is going to come from Docker CE stable. Okay. So now
Yes.
just paste it here. Yeah, just paste
So
this.
do we need the container runtime in the master node as well?
Yeah, if you want to, we need it. But
Okay.
actually speaking, we don't need this. Okay, because only end of the day in your worker node only, right? All your pods are going to run. So, but still, if you want, sometimes what happens is, due to enough, resource, you can even make your master. We can even deploy the pods in your master also.
Okay.
Okay, so due to not sufficient enough of nodes, we can even make your master also to work as worker node. Okay, your control plane also will be working as control plane. Yeah, okay. Yeah.
Okay.
So what happened? Oh, this is all in Vignesh CentOS. Okay, okay, not bad. Let me understand this. Okay, okay, okay. Let me copy down this. Let me go to my vim slash etc slash. Okay, you understood, right? Everything was copied from Vignesh, not from root. Right now we are in root, right? So that's the problem here. So under etc we have this m.repos.d. Okay, here we should have upstream.repo. So if you observe here, see everything is from Vignesh. So it should be root here. So sorry, this is the mistake. Okay, so that's
Yeah.
why I got that error. Okay,
Okay. I get
okay.
it.
Sorry, it should actually
So it should
be
be root no
root.
repo.
I'm so sorry.
Mhm.
Yeah,
Okay.
root.
Mm.
Then here also we have to mention the path. It should be root
Okay. I get it.
slash run media root. Yes. Now I think this should be correct and it should be working fine. Now let me run yum clean all and m repo list all. Fine. Now let me paste this command container d. Oh, what is this? Every time I'm going to see this command only. Oh, recently
Mm.
copy down this part,
Yeah,
right?
you just copy it and
Yeah.
paste it. Yeah, that's fine.
It's like, okay, let me copy down this. Let me go here. I think once you copy your system part, I think that's a problem, I guess. Yeah, container D. Now it should get installed successfully. It should not create any problem now. Now you can see your container day.io has got installed successfully. From which
Mhm.
repository? From your Docker CE-stable repository. Okay. So yeah. So we have installed successfully the container D, the runtime. Next, we have what and all we need. We need for setting up for a cluster, we need to install Kubernetes, right? Yeah. So next thing is we need to start and enable the service of container D. This is also important because only if it is active running, only then we can able to make the containers to run. Okay. Yeah. So now let's go to the worker node and master node. Both the machines, just paste this. Okay, so it'll be up and running. Yeah, it started up and running and it is okay. Now same way, go to this master node also. In master node also, you paste this. Okay, it should be up and running. Yes, it is successfully running and enabled. Okay, yes, fine. So what is the next step after installing this container? I mean container D. The next thing is we need to generate a configuration file for the container D. Okay, we need to generate a configuration file. So why? Because see, end of the day, we need the system C group to be true. Why we need this? Because only then your kubelet is going to use this system DC groups. Okay, if it is not using system DC groups, then it is impossible to communicate. I mean, it is impossible to communicate with the nodes. See what happens here is, when you give the system C group as true, what will happen is, we know, right, the end of the day our kubelet is the one who is going to communicate with our worker nodes to get the resource details, right? As or no?
Yes.
So that's the reason we have to make this true. So first, what you do, first we have to create the configuration file for your container D. How do you do that? You have to run this command to generate a configuration file. Okay, so okay, copy down this. Okay, go to your worker node, paste it over here. Yes, successfully it has generated one configuration file. See, you can see now it has generated the configuration file. Okay, same way in master also you have to do this. See, the command is simple. We are actually generating a configuration file. What is config.toml? Okay, for your container D. Now, what you do is you have to go to that particular config.toml. Under etc, we have this container D, right? Container D, and under container D, we have this config.toml, right? We have to go here. We have to change. mm, we
Group.
have we have to change from system C groups. You can see, the system C groups. We have to change it to true.
Mm-hmm.
Okay, we have to change it to true option here. Okay, save this and come out. Same way here also you have to go here. Okay, that is vim under etc. We have this container D, and over here you have this config.tyml. Go here, then at the somewhere over system DC groups. Where is that option, man? I think I went too far, I guess.
Perfect. Yeah.
Yeah, where system C groups. Where is that? Where is that? Where is that? Ah, here it is. Okay. Yeah. See, you can see a plugins.io continuity CRI v1 runtime. Continuity runtime run C options. Okay. So these are some run C options. So what you have to do is we have to make it as true option here. Okay. We have to give it as true. After doing this, what you do, see, since you have done some changes on the container D service,
Yes.
we have to restart the container D service, right? Yes or no? Systemctl restart container D. Got it right? Oh, I'm so sorry. What is that? Service name systemctl restart. Oh, container D only. No, let me check it. My notes. So after doing that, we have to run this command systemctl restart container D. Correct only. I think there's some spelling mistake or what? Failed to container D service not found. What the heck, man? See, anyway, so you can observe here. So we have restarted our container D. Okay, I think yeah, okay. Now let's go to the K8 master. In the K8 master also, let's restart. I think I have done the changes, right? Yeah, it has restarted successfully. Okay, got it right?
Yes. Yes.
Understood, right? Till now, what we have done, see, very simple. We have generated a configuration file for your continuity and we made this system C group to be true. Why? Because only then your kubelet can able to use this system DC groups to get the system resources. Okay, yeah. So that is what. Then we need to install this Kubernetes tools for all the nodes. Okay, so basically we are trying to install a repo file. Okay, see, this is the repo file, kubernetes.repo file. Okay, and the repo name is Kubernetes. Okay, repo ID is Kubernetes, repo name is Kubernetes, and this is the URL, base URL, because this is the place where we are going to install packages. Okay, now let's try to copy down the entire thing. Go to your worker nodes as well as the master node, both the machine you have to install this. Okay, so successfully we install the Kubernetes repo here. Same way here also we need to install the Kubernetes repo. Yes, successfully we have done this. Kubernetes repo has been installed. What is the next thing we have to do? We have to install the packages. What are the packages that we need to install? Kubelet, Kubeadm, kubectl. Got it right?
Yes, yes.
Okay, simple steps only, right? Not that much complicated, no?
Yeah. Mm-hmm.
Copy down this. Now go to your worker node. In your worker node, just paste out this, install these packages. So first we'll try to install all these packages. Yes, this should get installed. Come on. Yes, yes, yes. So same way in master also, go here, just install these packages. What happened? I think it should get installed. Yes, slowly getting installed. Here also it should get installed. Yes, it's getting installed. So after installing all these packages, what is the next step we have to do? So you have to generate a token. Okay, how do you going to do that? You have to initialize your cluster by running kubeadm initialize pod network CADR is equal to this network. Okay, so but before doing that, see, before doing that, we have to resolve the host name on both the sites. Okay, we need to resolve the host name on both the sites. How you are going to do that? So let me copy down the IP address of this machine, IP space A. The IP address of this machine is 192.168.73.130, right? Okay. Let me go to the host configuration file. Under etc, we have this host configuration file. Over here, I have to make sure my machine is following this. Okay. 192.168.73.130, right? Is that correct? K8 hyphen worker. And what about my master node IP address? So what's the IP space A? It is one, okay, 73.192.168.73.129. Okay, not bad. 192.168.73.128, right? 128 K8 master.
129.
Oh, 129.
Yeah.
I'm so
Check it
sorry.
out.
Yeah,
You know,
129. K8 master, I guess. Yeah. So this is how we resolve the host name. We are trying to resolve the host name here. Okay. So this is 129. Yes. Good. So next here also we have to resolve the host name. So you have to go to your master node that is under etc. We have this host configuration file. So here also we have to resolve the host name by giving the IP address 192.168.73.129 is your K8 hyphen master. Okay, then 192.168.73.130 is your worker K8 hyphen worker. Okay, yeah. So right now you can see here I have changed my host name to K8 master, and same way I have the host name as K8 worker only. Okay. So next thing, what is the next thing I have to do? So we have to go to the master. In the master, we have to initialize the okay, we have to initialize this particular cluster. So now when you initialize, what happened, that K8 master will actually act like a control plane. Okay, will act like a control plane. Once it acts like a control plane, then you'll be having this API server, then you'll have that control manager, then you'll have the scheduler, then you'll have that etcd. Okay, yeah. Then it is going to generate a token. So with the help of that token, we can make our worker node to communicate.
connect.
Connect,
Mm-hmm.
exactly, we can make it to connect. So after doing this, we have to also do these changes. Okay, because see, end of the day, this is the config file. Okay, end of the day, we'll have a config file. Inside the config file only, we have the entire cluster setup. Okay, we have the entire cluster setup. So make sure you need to have the access for the config file, so then only you get the entire cluster setup. Okay, so what we're trying to do, inside the user home directory, we're creating a .cube folder. Over there, we are copying down this particular uh, config. Okay, inside this config file. Okay, inside this config file, we are trying to copy down all this admin.conf inside this config file. Okay. Mm, yeah, I think the inodes, I guess it is trying to copy the inodes of this admin.config to the config. Okay. Then next, we are changing the ownership and group ownership of this configuration file as root user. Okay. So we are doing all these three things. Only then the root user can able to access this config, or any normal users can able to access this config file. Okay. Yeah, so let us try to do that. So once, let me, I have copied down here. You have to do only on your master node. Okay, don't try to do on your worker node. Now let me paste this part here. Once I paste here, now my master node will act like a cluster. Now I should get this. What happened? Oh, system RAM memory is minimum 1700 MB. Okay, I think I should have created 3 GB of RAM memory, man. Wait, let me, I should power off my machine, I guess. Oh shit, I forgot. See, this is what minimum in your master node, you should have 4 GB of RAM memory.
Okay.
Otherwise, it'll create this problem. Okay. So let me increase the memory. Let me increase to 3 GB. So now it'll be helpful to me. Okay. No, fine. 4 GB is fine. Okay, give okay here. Power on now. A lot of blockage, man. Yeah,
Mm.
today. I think even my worker nodes also might dip. Might even ask, not sure. Let cross check. I think even it'll also. But see, make sure this is all the default settings. Okay, you need to have two CPU core processor. Okay, two CPUs and minimum 4 GB if it is like a control plane. I mean, if it is a master node, you need 4 GB. If it is worker node, also you need 4 GB RAM memory and two core processor should be there. Okay, make sure these two setups should be there here properly. Okay.
Okay.
Yes. Now I need to run this particular command. Login as super user, that is root, and mention the password here. Yes. Now let me open the terminal. Open the terminal here. Operating. Make sure the swap should not be enabled. Okay. So let's cross. If you want, you can cross check it by running free-h. Okay. Yeah. So let's cross check whether that swap is enabled or not. Free-h. Swap is not that good for time being. So I have free space of 1.6 gigabit. Okay, RAM memory. Uh, okay, let me cross check this. But I have available of 2.2 GB. No, I think this time it should work. Okay, now let's wait. It is taking some time. Let's wait. Okay. Let's wait. Let's wait. It'll take some time. Let's wait. Then next, what if do? See, you forgot something. What is the next step we have to do? We have to install the CNI, right? That is cluster networking interface. No, right? See, till now, what you have done, we have just initialized it. Okay, once you initialize, you get that cluster, all that you get it. Okay, you get your master node, all that control plane will be there. Everything will work. Okay, but thing is, it will not be up and ready. It will not be up and ready. Okay, so if you want to make it up and ready, then we have to install the CNI part. Okay, only when you install the CNI part, only then you get it. So where is the token? Man, it's taking a lot of time. Okay, see, you can see here it has created control manager, it has created scheduler, then a lot of things. It has created a lot of things. Okay, so next we need to run this command. See here itself they have mentioned here. You need to run this command if you're a normal user or anything. Okay, if you're a root user, you just if you run this single command, that is fine. Okay, anyway, just have a practice like how you do it for normal user. No issues. Even if you want, you can run the single command. That is also fine. So you can run any one of this command. Okay, so let me paste it out this part and give enter here. So anyway, fine now. See, you need to understand here, this is the config file, okay? We'll have the entire cluster setup will be inside this config file only, okay? Yeah, this config file is very important. Okay, next thing is, so now we got this token. You can see, Kubeadm join the 192.168.73.129.6443 and the token is this. So now we have to tell our worker node to use this to connect to our master node. Is it clear?
Yes, yes.
Yes, but before that, what we need to do? We need to install the network.
Networking.
Okay,
Yeah.
why? Because see, if you observe here, when you run cubes, it will get nodes here. I get this. Basically, I get this K8 master. Okay, but it is going to be not ready state. If you want it to make up and ready state, so first we need to create the networking part, cluster networking part. So only then we can. It's going to work. Okay, so now how to do that? We have this command CNI for master. So copy down this, go to your master node, just paste out here, give enter here. So now definitely when I give enter here, now it is going to install and yeah, buddy. Now I think if you stick here, still it'll take some time. Okay, let's wait. It'll take some time, but it'll get up. Okay, it'll be up. Now meanwhile, I'll try to copy down this particular part. Okay, I'll copy down this part.
So we are not going to install the networking things on the worker node.
No, not required, not required. That's what. See, your end of the day, your master only is going to have a network connection with your worker nodes. Okay, so it's like only one-way connection only. No, we don't need to have two or three. Okay,
Yeah. Okay.
so yeah. So let me paste it here. Let me give enter. Now even this also should be connecting to my now you can able to see. Let's say for example, if I try to see kubectl get node. So basically we have this command kubectl. Okay, so basically this is a CLI command. Okay, kubectl get nodes. I'll explain anyway. When we go with commands, you'll get to know. See, now your master is ready, whereas your worker is not ready. So we have to, let's wait until unless your worker is going to get ready. Okay, it'll take some time, just wait. Okay, so it'll take minimum like 1 to 2 3 minutes to make it up. Not ready. Come on, get ready, man. What happened? What happened? What happened? Still not ready. See, now you can see both are ready now. Okay, both are ready. Understood, right? See, not
Yeah.
only that, we have a lot of services, we have a lot of other things, we have a lot of namespaces in your Kubernetes. Okay, we'll understand what is namespaces, we'll understand what is pod, we understand what is nodes, all that we'll understand in the upcoming session. But right now, what you need to understand is whether our pod is going to run or not. Okay, whether our pods are going to run or not, or whether this particular setup is been working properly or not. So first, we'll check all the services. Kubectl get all hyphen a. When you run kubectl get all hyphen a, you could able to see that yes, everything is up and running. Yeah. So we have some namespace like cube system. We have a namespace like default. Okay, we have a namespace like what is that? Cube. Lot of namespace are there. If you want, you can check it by running kubectl get ns. I'll explain what is namespace when I go to namespace. Okay, I don't want to discuss more detail right now. Okay, now we'll see how to deploy a pod and we'll make sure how that is actually running in your worker nodes. Okay, we'll cross check that. Okay, now what you can do here is simple thing. So anyway, we made our worker nodes to connect, right? Okay, fine. Now all these are there. Now I'll create one deployment file. Okay, we'll copy down this entire deploy. I'll explain this when I go with the next session. Okay,
Okay.
so
Yeah.
you'll
That's.
understand how to create this file and all on what is this match label indicates, what is this metadata, what is this spec, what is this kind indicates. You will understand slowly. Okay. Right now, what I'm going to do here is I'm just going to create one deployment.yaml file, which means, see, end of the day, I'm actually creating a pod. And inside the pod, I'm going to run a container like nginx. Okay. And that container is going to listen to the port number 80. Clear, right? Is it clear?
Yes.
Okay. Yeah. So let's try to do that. So now let's go to my where is this worker node, master node. So in my master node, I'll create one file. Okay, vim deployment dot yaml. You can give whatever name you want, it's up to you, but dot yaml extension should be there. Okay, dot yaml extension should be there. Now save this and come out. Now if you want to execute this particular manifest file, you have to run this command kubectl. Okay, deployment dot yaml kubectl apply. See, I forgot this kubectl apply hyphen f, the file name, deployment.yaml. So now I think you can see this particular nginx deployment has been created. How do you check that? You can check it by running kubectl get pods. Okay, so it is in container creation. Okay, let's wait. Let's wait. It takes some time for creating your containers. Okay, so now where these containers will be stored? It will be stored in your K8 worker, right? End of the day, it's going to be in your K8 worker, yes or no?
Yeah.
It's going to be in your K8 worker, right? Yeah. Yeah. See, now you can see it is up and running now. It is successfully, it is up and it has been running. Okay. It is up and it has been running. Okay. Now, if you want, you can even check the deployments, like how many deployments you have done. 2 copies of deployments. kubectl get deployments. Kubectl get deployments. So you can see here we have created 2 deployments, which means we have created 2 pods. Okay. We have created 2 pods. Okay. You'll understand what is this deployment, all that you will get to know later. Okay. If you want to expose it over the internet, okay, or if you want the outside people to connect to this particular pod, we have one particular service. Okay, you can use for external thing, we can use node service, you can use load balancer, you can use all that. And to connect to that particular application, you have to use the port number, that is the IP address of your worker node, followed by 3007. Okay, let's create one service.yaml file. Right now, I don't want to go more discussion about this. Okay, we'll understand this. We'll understand slowly. Okay, service.yaml file and paste these things here. See, what we are doing here is we are actually creating a type node port. Okay, and by default, the node port number is see, by default it should be more than 30,000 only. So we are giving 30,007. Okay. Yeah. So what this node pod will do is this is actually an external service. Like it actually makes a pod to, I mean, it actually makes a pod to communicate externally. Like if there is any end user who wants to check this particular pod application, okay, they can use this particular port number. Okay, so if they are getting this port number, which means this pod has been externalized. It's been externalized, so it has been exposed. It has been exposed. Okay, it's been exposed. So now I have run this. If you want, you can check it by running kubectl get svc. Oh, what happened? Kubectl get svc. Okay, so this is cluster IP. So for you have to give cluster IP. One second. svc hyphen a. Okay, so it is giving me this all that. But if you run kubectl get pods hyphen o wide, you'll get the IP address of the pods also. Okay, you can see here when you run kubectl get pods hyphen o wide, you get the IP address of the pod. Okay, that is 192.168.125.66, your K8 worker. So it is working on K8 worker nodes. Okay, both are actually working on K8 worker nodes. Clear, right? Are you getting this?
Yeah, yes, yes.
Okay, so both are actually in worker nodes, and it is having an IP address 192.168.125.66 and 65. Okay, let me do one thing. Now let's try to cross check whether we could able to see the applications or not. So yeah, so you can give the worker IP followed by the port number. Okay, this particular understood, right? One is there. What about this one? Did I give kubectl apply, right? I gave kubectl apply. Oh, I didn't give kubectl apply hyphen f service.yaml. Oh, okay. Shit. I'm so sorry, man. I forgot to give this. I forgot to apply the service only. So that's what I was cross checking. Why it was not coming up. Yeah. No problem. Now, oh, okay. Now what we have to do here is connect that particular application. Okay, so we have to have the worker IP. So if you look at the worker IP, so kubectl get nodes hyphen o wide. So if you observe here, we have the worker IP for this particular machine as 192.168.73.129. Copy down this, go to your, I think it's almost there. Here just need to mention that node port number. So you can say welcome to Nginx. If you see this Nginx page successfully, yeah. So this is how you actually work. Okay, so that's it for this session, guys. Thank you all.